sources of sound, Doppler effect, and shockwaves. We're going to talk about two sources of sound, vibrating strings and air columns. Musical instruments provide sounds in a variety of ways, but they have one thing in common, vibrations. The vibration may be started by plucking, striking, bowing, or blowing. The vibrations are transmitted to the air and then to our ears. The strings on a guitar can be effectively shortened by being pressed down on, up here, and that will raise the pitch. The pitch of a string of a given length can also be altered by using a string of different density or thickness, where you have a different speed of sound in the string. A piano uses both methods to cover its more than 7-octave range. That's 8 notes in an octave, so that's a lot of notes. The lower strings, over here, are both much longer and thicker than the higher ones. Based on this information, how would you describe the sound made by the higher strings to the right? Well, they would have a higher pitch. They are higher notes. As you move from left to right, and actually I already gave you the answer in the previous slide, the strings get shorter and thinner, which results in a higher frequency sound and pitch. Now we're going to talk about air columns, which are found in tubes, and differently shaped tubes here. Wind instruments create sound through standing waves in a column of air. Depending on the instrument, that column will be open at one or both ends. Okay, here's a bassoon. It looks like it's open at both ends. And clarinet, open at this end, closed at that end. Let's talk the Doppler effect now. Have you ever heard a police car approaching and passing you? What does the siren sound like? So here's the car going in this direction. If it's going away from you, it should have a low frequency sound. It has a long wavelength. If it's approaching you, it has a small wavelength and a high frequency, a higher pitched sound. The pitch, or frequency, changes as the police car passes. The pitch is higher when it approaches you and lower when it goes away from you. The Doppler effect is a change in frequency of a wave for a wave source moving relative to an observer. So here's your observer. So as the police car was approaching this person, high frequency. When it was moving away from the person, just like over here, it has a low frequency, a lower pitch. The waves look different on the left and right side of the car as it moves towards the person in the blue shirt. The waves get closer together on the right side, right over here, which results in a higher frequency, and further apart on the left side. That's a lower frequency. Since the Doppler effect exists when there is relative motion between the sound source and an observer, it also works when the source is stationary and the observer is moving. If the observer is moving towards a stationary sound source, she will hear a higher pitch. Shockwaves. All these examples have been for an object traveling slower than the speed of sound. What if the sound source is moving at the speed of sound? When this happens, the waves all add together here in the direction of the motion and get very powerful. That's constructive interference. That's called a shockwave. When these waves strike us, we hear a sonic boom. Some planes can move even faster than the speed of sound. As the plane travels, it passes over an observer on the ground before the sound even reaches them. This is called supersonic flight.